friends and viewers, welcome back to our channel and Vinay Kumar Basics of Physics. This is the right place to learn physics. Dear friends, in this video we are going to discuss about the PN junction diode reverse bias. In reverse bias, how the PN junction diode can works. So that is the topic for this video. If you want to understand the topic, watch the video till end. Clear? So what is the PN junction diode reverse bias connection? When in a PN junction diode, P-type material is given to negative terminal of the battery and N-type material is given to the positive of the battery, then the PN junction diode is said to be in reverse bias. The connection should be like this. Here children, the circuit symbol of PN junction diode is this one. This is the circuit symbol of PN junction diode. This is the P and this is the N, and this is the battery. Clear? If it is given like this, it is the forward bias. Clear? If the same PN junction diode should be connected like this. Now it is reverse bias. You have to remember these two very clearly. When P-type material is given to the negative terminal of the battery and N-type material is given to the positive of the battery, then the diode is said to be in reverse bias. This is the reverse bias connection. What happened when the PN junction diode is connected in reverse bias? Let's see here children. So this is the P-type material and this is the N-type material. So I think you have idea about the what are the majority charge carriers in P-type and what are the minority charge carriers in the same P-type, and what are the majority and minority in the N-type material. In P-type, holes are the majority. In P-type, holes are the majority and electrons are the minority. Similarly, in N-type, electrons are the majority and holes are the minority. Clear? In P-type, holes are the majority. In N-type, electrons are the majority. So now here, let's see here. When P is given to minus and N is given to plus, what you observe here, the negative charge is given to the P-type material. It means that already we know that what is the charge of hole? Hole has positive charge. That's why these holes are attracted by the negative terminal of the battery. Due to that, the holes are moving away. Holes are moving away from the junction diode barrier or depletion layer. The holes are moves towards the negative of the terminal. That means the holes which are in the P-type material near the junction, they should be moves away from the junction. Clear? Similarly, the electrons which are the majority in N-type material, they are also attracted by the positive of the battery. So what we know, like unlike charges always attracts each other. That's why these electrons are moves away from this depletion layer or barrier. Then obviously here what we know, from this depletion layer or barrier, the holes and electrons are moves away. They are not enter into the barrier. They are not enter into the depletion layer. The particular barrier is there. So these holes are not moving from P side to the N side, and electrons are not moving from N side to the P side. That means what? There is no diffusion is going on in that PN junction diode. That's why in PN junction diode reverse bias, there is no diffusion current. Almost all it is zero. Already we know what we diffusion current, moving of holes from one side to the another side, and electrons are moving from S. The majority charge carriers which are in the p type and n type, they are moving from one side to the another side. That is what we call diffusion of current. I clearly explained in the previous video in the topic of the PN junction diode forward bias. So up to now we didn't see that one, just go for that once. So here children, now when holes and electrons are moving away from each other, it means that no majority charge carrier do not cross the depletion layer or barrier. That's why diffusion current should be taken as 0. That's why simply from that statement what you have to conclude, while they are not moving or across the junction, simply there is no diffusion current. That's why here what I have to say, the barrier potential or the thickness of the depletion layer is going to be increased. The resistance of the barrier is going to be increased. Why? Because there is no moving of any charges from one side to the other side, especially talking about the majority charge carriers. While the majority charge carriers are not moving from one side to the other side, obviously here the barrier resistance is increased and barrier potential also increases. That's why simply here children, what you have to say, in this one diffusion current IDF is 0. Clear? That's why almost all in reverse bias we have to say that almost all there is no current in reverse bias. We will discuss, we will conclude. Why? Because diffusion current is 0. But there is a small less amount of current is there. That means what? Some drift current is there. Why? Because how it is possible? Means simply here the minority charge carriers which are in the p type and minority charge carriers in the n type, they can move across the junction. That's why there is some little bit current is possible. The current should be called as here leakage current or reverse saturation current. How the reverse saturation current takes place or leakage current takes place? Simply the minority charge carriers in the p type and n type, they can be crosses the junction. Very less amount of minority carriers will cross the junction. How they can cross? What's the reason behind that? Here children, in p type material, electrons are the minority. And in n type material, holes are the minority. So in p type, holes are so many there and small number of electrons are there. Here more number of electrons are there, here minimum number of holes are there. So here it is given to negative. That's why here some of the electrons are repelled by the negative charge of the battery. That's why they can cross the junction. Clear? The electrons which are the minority, they can be repelled by the negative of the battery. That's why they can cross the junction. And similarly, which are the minority charge carriers, they should be repelled by the positive of the battery. That's why they can cross the junction. That's why some leakage current is possible or reverse saturation current is possible. How the reverse saturation current is possible? The minority charge carriers which are in the concerned p type and n type, due to the repulsion between the opposite terminals of the battery, they should be crosses the junction. That's why some drift current is possible in the PN junction diode in reverse bias. So here the amount of drift current should be is more than the diffusion current. In the diffusion current means what here? Diffusion current is almost all 0. You have to remember that children. The main key points here, the first thing is when P is given to negative and N is given to positive, then the diode is to be in reverse bias. And second point is what it is? In diffusion current, in reverse bias, diffusion current is 0. Why? Because there is no moving of majority charge carrier from one side to the another side. And third one, the resistance of the barrier is going to be increased. Why? Because no majority charge carriers can cross the junction. And fourth one is a little bit of current is possible in the reverse bias. That is because of minority charge carriers in concerned p-type and n-type material. That is possible because of repulsion between the charges supplied by to the battery to the concerned minority charges in p-type and n-type. So children, this is about simply about the reverse bias connection of p-n junction diode. It is more than enough for 4 marks. Okay, thank you for watching.